Okay, so how we see the blockchain world is in 3 generations, right? Like, so the first blockchains were launched at some point, right? Like, it was a single chain, single asset blockchain. There was Bitcoin, there were some before, there's also Zcash, right? Like, you have one chain, you have one single asset. Then eventually there was an innovation with Ethereum that opened up the space to multiple assets now, right? We don't have only the native token, but now we have many tokens, we have NFTs, we have all kinds of real world assets. And how we see the next progression of this is multi-chain networks, right? So we have multiple blockchains in a network with multiple assets. So what that really means is we're going from a single blockchain with a fixed validator set to a network of heterogeneous blockchains with different validator sets. Why should we do this, right? Like, and the answer to this is independence, scalability, and compliance. And I'm going to touch on all of these a little bit, and more than happy to answer any questions. But from these, you may already see we're heavily targeted at enterprise use cases, right? Like big financial institutions, government organizations, and all this. All right, so let's start with scalability. And I want to talk about blockchain performance. So in the previous talk, you already heard a lot about TPS, transactions per seconds, and everything, right? And when we think about the performance of a blockchain, I want you to go with this very simple analogy of a highway, right? So we have a highway, and each of the cars on the highway is a transaction. Right? They all travel with the same speed. We're going to simplify it. And what does it mean to enter a highway? It means in our wallet, we're clicking send. And we exit the highway when this transaction is finalized on chain, right? Like, this is written to the chain. It will never change again. We are finalized now, right? So this is our very simple kind of thought model here. We're going to stick around in my presentation. And we have 2 metrics here. And it can get very, very tricky when you enter the space because they seem very similar, but they're actually very, very different. The one is time to finality. I click in the wallet. How long does it take until the blockchain confirms that my transaction is finalized, right? Like, this time is completely independent of how many transactions my system can process, right? TPS, right? Transactions per second means how many cars can enter the highway at some point. It doesn't have anything to do with how long the cars are going to be on that highway, right? This is very important. And when we think about a blockchain, this mental model really helps and really makes us understand that these, can be very, very different. And when we build a blockchain, right, it's kind of like, what kind of highway do we want to build? So let's imagine we want to go from Munich to Berlin, right? What we want to build is a highway that goes the most direct route, right? Doesn't take any detours and has a decent number of lanes, right? What we don't want to build is a single lane highway going through the middle of nowhere, passing through Paris. And it takes forever. It gets easily congested because it's only a single lane, right? So if we look at blockchain systems out there, we see Bitcoin is from a performance point of view, and we're just talking about performance, not about decentralization or anything else, right? Just the performance is a single lane highway that takes incredibly long, 60 minutes and easily congested. I think 7 TPS to go. So very limited use case. Ethereum is better, right? Takes only 15 minutes, but still not an incredibly high throughput because they are having 700,000 validators, right? Like, so they have to take compromises. Avalanche has around 2,500 transactions per second, right? The throughput, and a finality of below a second. So we could be happy with that, right? But if we think about 2,500 transactions per second is nothing. If we want to bring something like NASDAQ on chain, if we want to bring many of the interactions we have today and where we trust systems in the Web2 world to chain, we will need a lot more, right? And now is the question, what are we going to do? Are we going to try to build that highway wider and wider and eventually even sacrifice some of our time to finality? And we at Avalanche think that we're not going to have a single chain anyway, eventually, but we will have a heterogeneous network of blockchains. So what does that mean, right? So we have subnets. The first one is pretty easy. It's a primary network, right? We take all the Avalanche validators, they validate a blockchain. That's a primary network. We have one blockchain, fair enough. But what we're going to do now is we're going to take a subset of the nodes of the Avalanche network, and they're going to validate a different blockchain completely independent of the primary network. And then we're going to do the same thing again, right? And nodes, a subset of the nodes on the Avalanche network are going to validate more and more blockchains. And these may overlap, right? A node may validate 3 or 4 subnets. But eventually, we will see that, like these subnets increase the throughput of the overall network by a lot without, like introducing additional complexity. We don't have to sacrifice short time to finality, right? Is that clear so far? I see some people nodding. Good, awesome. Cool, so this is the general idea of subnets, right? And we just saw kind of like how this, in our opinion, solves scalability, because now we don't have to introduce ZK or anything else, right? We can just scale with taking subsets of the validators. But there are like some pretty nice side effects that are interesting for institutions. So what we saw already, the fees, right? Like, so these are the Ethereum gas fees on the Ethereum network. And we see massive spikes here, right? Like usually it's pretty cheap, but on some days it just goes through the roof. And there are some times in the bull market where for many business use cases, this chain gets completely unusable, right? If you are, like let's say you're a telecommunications company, you can't afford that your gas fees just spike like 3, 4, 5x, because this will ruin your whole business model, right? Like we are also in industry with margins that are not like 300%. So we really have to see that we isolate fees. What we just see is when we have different layer 1 blockchains, these are completely independent, right? The idea of fees is if there's high network usage, fees go up to disincentivize people to issue transactions, right? It gets more expensive. Similar with flights or whatever, right? Like if we have these different blockchains, independent blockchains, each of them has an independent fee market, right? So if there is a lot of traffic on one subnet, the fees will go up. Other subnets are not affected at all. But also we have customizability, right? So let's think like we have a highway, but we also want to have, like something where people can travel with a boat or with a train, right? While it's technically possible to build this all on one, highway, dig out one lane, fill it with water, put on some tracks, it gets very, very tricky, right? It is much, much easier to make these customizations in independent systems, right? So when we look at the EVM, we have a few modules there, right? Like we have the consensus layer, we have the execution layer, the EVM, and then the Solidity smart contract. Some of this you saw earlier today. If you look at the Avalanche stack, we have a shared consensus layer. Then we have different execution environments and different smart contract layers. And this is actually very, very powerful because now we can make easily some customizations to the EVM without, like introducing these customizations to the entire network. If you've had the pleasure of suggesting a change to Ethereum, this is a very, very lengthy process, right? Like you've suggested in the forum, you have to rally for it. You will eventually, 1.5 years later, if this comes like to the point where the community accepts it, you will be as lucky to have it included. However, it's always a compromise between the entire participants of the chain, right? Like because it will have to benefit everyone. If you're an institution, if you launch your own chain, you can do whatever you want with the virtual machine here. But it's even more powerful, right? Like we can see that we are completely VM agnostic. We heard some questions about the EVM earlier. Pretty good stab at the first virtual machine, I would say. There are definitely improvements, right? So we have a team, for example, if you're familiar with Aptos and Sui, they're building a Move VM in the Avalanche network. So on the same level, it's an interoperable chain in the Avalanche network running a completely different virtual machine. We could also see, actually, I would love to see a team actually building a Solana VM or some other VM because we think just the diversity of VMs is a really great strength for our network. And we already are having an internal team building actually a WASM VM where you can write programs in Rust. And then the last part, especially relevant for governments and institutions, is permissioning. And I want to be very clear, this is completely optional, right? We can do permissioning on many levels, validators, smart contract deployers, and users. And at this point, like sometimes, like people get up, leave the room, are like, we're on blockchain, what are we doing this for? It's for a permissionless world, right? And I believe that. And I really want the world to be permissionless and everything accessible to everyone. However, the reality is, many of the financial institutions we see today, many of the governments, they completely act in hiding. So I'd rather see them on a public, auditable blockchain with permissioning than in a completely closed off system. And we think this is a good stepping stone to a future where we have, a lot more accountability, right? So what does validator mean, right? Like for some applications, let's say in the European Union, if you want to work with health data or whatever, you can't store this data outside of the European Union. So you can, for your subnet, permission the validators to all be in the European Union. And therefore you can be compliant, right? This is the first one. Another one is that you can permission who can interact with your blockchain, right? Who can deploy a smart contract. If you are a financial institution and you launch your institutional blockchain, you want to be very, very sure that not a random user is coming along and is deploying Tornado Cash to your chain, right? You can get in very, very, very big trouble. So also, if required, as I said, also completely optional, you can also require your users to go through some kind of KYC process to interact with your chain. Right? And this way, I think we can enable many, many enterprises to, even now with a lot of regulatory, the situation is unclear, to stay compliant, move on chain, and then eventually open up as soon as the regulation kicks in. Yeah.